Welcome back. So this session we are going to discuss about autonomous first order differential equations and introduce different methods of solving ordinary differential equations. So definition: an ordinary differential equation in which the independent variable does not appear explicitly is said to be autonomous. So for example, if x denotes the independent variable, then an autonomous first order differential equation can be written in the form or in normal form we have dy dx equals to f of y. So that's what we have as an autonomous equation, differential equation. So examples: so if we have dy dx equals to 3y, say dx dt equals to 2x squared, say dy dx equals to 1 plus y squared, dx dt equals to sine t, equals to sine x, etc. are autonomous. While if we have equations of the form, say, dy dx equals to 2xy, dx dt equals to 3 sine x plus t, are non-autonomous. So many physical or many differential equations encountered in applications or equations physical laws do not change over time. Are autonomous. So examples of these models of differential equations, if we have the A, dt equals to Ka is an autonomous model or differential equation. Dx dt equals to Kx into n plus 1 minus x is also an autonomous differential equation. Say dt equals to Kt minus Tm. This is the Newton law of cooling. If we have the A dt equals to 6 minus 1 over 100A, all these are examples of autonomous differential equations. Now, there's what we call critical points. So the zeros of the function f of y in this differential equation dy dx equals to f of y are called critical points. That is a real number C is a critical point of the autonomous system dy dx equals to f of y if it is a zero of f of y, i.e., if you put this C in f, you get 0. Now, critical points are also called equilibrium points or stationary points. Now, after defining the critical point, so for instance, if we have dy dx equals to 2y plus 4, then the critical point is taking 2y plus 4 setting to 0. So which implies 2y equals to minus 4. So y equals to minus 2. So therefore, minus 2 is a critical point. Now let's discuss about a special kind of differential equation, what we call separable differential equations. So some types of first order linear differential equations. So first class of equations that we are going to be dealing with are what we call separable equations. So definition, if an equation can be put in the form phi of x or phi of y dy equals to psi of x dx, then such so if an equation can be put in this form such that the left-hand side is a function of y only, and right-hand side is a function of x only, we call such an equation such a differential equation separable. To solve such equations, we simply integrate both sides, i.e., integral of phi of y dy equals to the integral of psi of x dx. And then we add a constant of integration. So where c is a constant, of integration. Now, in next session, we demonstrate how we solve separable differential equations.